I thought he was going to say he was going to miss his credits, and then I was going to leave him off behind. Luckily, it was Matthew Rumpel. I can't compete with Matthew Rumpel. Okay, so product and quotient, guess what we're doing? Multiplying and dividing. Same thing with the notation. It can be f of x times g of x, or it can be f times g of x because the x's are shared again. Same thing with the division. You two aren't going to be allowed to sit together. There's like 9 people in the classroom, and I'm going to have to separate some people. Or it's going to be f divided by g of x. So that's pretty much the same notation. I want to point out this is going to affect the next lesson, composite functions. Multiplication is a closed circle. Multiplication is indicated by a closed circle because composite functions is an open circle. So just remember that the dot is multiplying. All right, so determine the product of the functions. So f of x is this, and g of x is this. Determine that and state the domain of range. Every time I look back there, there's more X's and O's on it. It's like it magically appears. I think the easiest way. Oh, damn. I think it's on from bad. You wanted to get through this lesson, and you think this is going to work? Okay. The best way to start this is to expand this one that's in vertex form and put it in standard form. So we all remember how to do that? Right? Yes, my math is good. I have faith that my math is good. So if this is my f of x, and I need to multiply this by my g of x, so h of x is going to be x squared plus 4x minus 1 multiplied by 3x minus 4. Why is it important that I use the brackets? If you don't use the brackets, that would indicate that -1 is multiplied just by that binomial. You need to say that this whole thing is multiplied by it. So the use of brackets is important here. So this is distributive property done 3 times. So I'm going to take that x squared and I'm going to multiply it by everything in the binomial. So I'm going to have 3x cubed minus 4x squared. Now I'm going to take the second term, that 4x, and it's going to be 4x times 3x and 4x times 4. So that's going to be plus 12x squared minus 16x. And now that -1 has to get distributed through. So -3x plus 4. I'm going to combine like terms. Squared. Thank you. And combine my x's, so yeah. Oh, sorry. Yeah. Thank you. You guys always on my back. I appreciate that. It is yeah, that would be a half mark. I would call it a transcription error. E7, a transcription error, notation error, because I had already written it here. So if I wrote a squared here, I just, obviously you know how to multiply, you just wrote it wrong. It's called a transcription. Pretty easy stuff. Pretty easy stuff. This is like grade 9. Multiply. So nothing really technical about it, but you'll have a heck of a time trying to do it in a vertex form into this. So I would just say put it in standard form and do the straight multiplying. Yeah, yes, it looks like a lot, but I think the other way would get way more cumbersome. Yep. Ooh. Yes. Cumbersome. Like, yeah, like it's bulky, it's hard to do, you get in your own way a lot, right? What did you say it was, Jerome? Hindered? That's it. Matthew? Hindered. Hindered, is that all? Okay, domain and range of this. Okay, so it's a cubic function with a positive coefficient. This is your chapter 3. So domain on an odd function with a positive coefficient. So it starts in where? 3 and 1. That would be backwards to you guys. 3 and 1 for me. And so that's going to be negative infinity to positive infinity. What about the range? Negative infinity, positive infinity. Okay. All right, so considering the functions, f of x is this, and g of x is that, determine the equation of the function of f of x. Look at this. What's on top? G. So we are going to have h of x is equal to 2x plus 6 over x squared plus x minus 6. Am I done? Can I go home now? Thank you. Okay, so this becomes a chapter 9 issue. This becomes a chapter 9 issue. Got to factor everything. So I'm going to have x plus 3 over x plus 3, x minus 2. Now, before I get excited and start canceling stuff over, I have to do NPVs. So my non-permissible values will straight over here. Non-permissible values are x equals negative 3, x equals a positive 2. Now I can cancel some stuff out. X plus 3, so h of x is equal to 2 over x minus 2. X cannot equal a negative 3 or a positive 2. Can you cancel those 2's? No, I didn't know that. Don't do that. Don't do those people. All right. Oh. So here, combination of chapter 10 stuff and chapter 9 stuff. You got to graph a rational equation. Easy peasy, right? Actually, we have to graph f of x was a parabola, g of x was a linear, and h of x is a rational. I need a set of notes that I don't have. I'm not recording. Yep. Oh, should be negative 5. I graphed it negative 5. Shouldn't it be negative a quarter? So what did I do? So that's a fourth. That's a positive fourth. Plus a half, which is 3/4. What? You're right. That's what I did wrong. Okay. How? Thanks. Whew. I was like, your math doesn't add up, my math doesn't add up. We are not doing well in relations and saves today. So, ooh, that's a good question. Somebody explain it to us. X is negative 1/2. I had it as plus 1/2, but it should be negative. So this would be negative 1/4. So this is going to be negative 6 and 1/4. Negative 6.25. Woo! That took me a long time to get there. It's Friday. Okay, now my vertex is all screwed up. That's okay, my Reynolds number will write anyway. Oh. It's approximately the same. Right? Oh my goodness, that took a long time. Especially when you screw up and then have to go again. So my h of x. Hey, is there any restrictions on the domain of my g of x and my f of x? No. So all values are okay for my h of x, except my h of x has some restrictions. Right. So the question is, which one's the whole and which one is the asymptote? Perfect. So the whole occurs at the one that you canceled it out. So the point of discontinuity, or the hole in the graph. So if I were to substitute negative 3 in here, what would I get? If I were to put negative 3 into this equation, what would I get?
Negative 1/3. No, it's not.
All right, there we go. That took a little while, but I can do it. Let's do it. So we have a point of discontinuity here, and then we have a vertical asymptote where? Okay, so I'll give you the equation now. You guys gotta go. You guys got to get okay and people see your face. Oh, turn the dial on the inside. Were you meeting there? Awesome. Hey, where is my horizontal asymptote? What? Thank you. How come? How do you know? Tell me how you know this. There's no thingy on the outside? Okay. There's no shift. Okay. We can also talk about the degrees of the numerator versus the denominator. The degree of the numerator is 0. The degree of the denominator is 1. So when the denominator is greater, it's up. Y equals 0. So I'm just going to draw these in because I'm really bad at crossing my asymptotes. Where's my point of discontinuity? Okay, so let's throw that in right now. So negative 3, and that's 0.4. Negative 0.4. Okay, so we got to at least do a couple of points. We've got to go back and grab some, we got to label some points because there was no negative values anywhere. So we've been calling it that for like months now. David values. Is that table of values? David values? You guys like to do all the time? What have you been drilling? It's been class drilling for a while. He's been sleeping. Yeah, okay. Thanks for pointing that out. And my class is that exciting. Okay, so let's pick another point. If I substituted 0 in this equation, if I substituted 0 into this equation, what would you get? If I put 0 in for x, -1. So 0 and -1. Maybe I should label that point. I probably want to pick some points. So we're guessing that this. We're guessing that this one's below. So I'm going to hedge a bet that this one is above. Would you guys be okay with it? Okay. So let's pick a point. If I were to put in, let's say so this is 2, let's put in 4. If I put 4 in there, x is 4, what's y? Positive 1. So this one is 4 and 1, that looks like a y, but it's really 4. So I would have this part going this way, and work on making sure that our graph is moving away from the asymptotes. What's your concern? We did do it this easy way in chapter 9. Well, I have 2 points. I have this one, which is 0 and -1. I have 4 and 1 here. Hey, your practice. Okay, things that are going to catch you up on the exam, make sure your points of discontinuity are labeled. Okay, make sure they're there. Y-intercepts if you've got them, make sure they're there. And x-intercepts if you've got them, make sure they're there. You get to label some points on the other graphs. My vertex, I got that one for sure. My vertex is -1/2 and -6 1/4. And this intercepts at 2 and 0. And then I need some points on the linear graph, so I'm going to use the x-intercept, which is -3 and 0, and I'll use the y-intercept, which is 0 and 6. A little bit messy, but I have 2 points labeled on each graph. I have each graph labeled, except for the purple one. We're going to put h of x beside it. So, and my increments are done. So those are things that I really probably should have practiced in January or whenever we decided that this was our time together. Okay, state the domain and range of h of x. I would do it as an exclusion statement if it was me. I would do my domain, so -infinity to +infinity, x cannot equal the +2 and -3 from the domain, right, from our non-permissible values. For the range, I'd also do y cannot equal what? 0, and there's one other place. It's my point of discontinuity. Okay. A lot of people forget that. It's not. XDR is fun. YER is fun. We just have consistently been using -infinity, +infinity in this class. I don't want to switch up now, and then I get voted on the others. Word problems. Okay. Local hockey team would like to boost support fan of the games who decides to reduce ticket price T in dollars according to this function, where G represents the number of games played. To further increase fan support, he decides to randomly give away noisemakers. The number N in hundreds of noisemakers can be modeled by the function map. Community fan base is small, but the owner notices since the incentives were put into place, attendance A in hundreds can be modeled by that. All right. That's good. Good. Determine R of G if T is T of G times A of G. And then we got to algebraically explain what it means. All right. Okay. So ticket price times attendance is going to give us, what did you say, Blaze? Makes sense, right? The people attending times the cost of what you're selling the tickets for is going to give you your revenue. So our, that's what we know, RG is equal to the revenue that you're going to bring into the game. That makes sense to everybody? You like it? Yeah, number of tickets sold times the price of the tickets. How much money we collect with that night? All right, so let's do math. So R of G is equal to T of G, which is 10 minus 0.1 G times A of G, which is 8 plus 0.2 G. You guys can do this in your head, right? Yeah, what you got? What? 10 times 5 plus 2G. All right, use the graph of the revenue formula that we have to determine whether the owner increases or decreases the revenue that ticket sales. All right, so do we want to describe it using technology? Yeah, seems reasonable, right? You guys know, I'm going to, that's not at all what I wanted. You guys know we're going to take your calculator away on Tuesday, right? Oh, harsh reality. Because you're going to have a non-calculator portion on your log extent. I think it's all everything until we get to the test and somebody else. And I cry on the inside, so I'd rather take it now. All right, so I clear all this stuff out. Okay, so I am putting in there negative 0.02 x squared plus 1.2 x plus and we graph that. My Window's not great. Windows, what? You know what we do? Do something different than that. I'll go back to graph. I'm going to zoom. That's not zoom. Zoom. Thanks. I'm going to do zoom, and you scroll down. It's zoom 0. You zoom fit. And if I select that, I may have to edit. Wow. It's thinking, everybody. It's having a hard day. It's thinking. Hey, so let's go old school. And what is it that we're going to graph? Is it going to be a linear? Is it going to be a parallel? Is it going to be a cubic function? What's it going to be? Parallel. Okay. Officially parallel. All right. And then we'll cancel that as we go follow. Get anything to come up? What, sorry? So we know what's going to open. So this would be my G, my number of games, and this would be my money on the y-axis. Will I have anything in quadrants 2, 3, and 4? No, everything's going to live in quadrant 1. I'm going to head to that. So this is my y-intercept, so I know I'm going to start at 80 and then have some sort of parabola that looks like that. Now I didn't put arrows on it because we just discussed them around, well, I could potentially have negative money. But I'm not going to have negative gains. That makes sense. So I could actually keep this arrow, I could put an arrow on that because it could technically keep going. What's the most important part of this graph for maximum problems? You can't have it on the same graph. So this graph has a max or a min. Has a max. It hits a max point. So what is that max?
No,
We do.
you don't have to do that. How many posts in the
Okay, because you're smart. So let's find the vertex. How do we find the vertex? Because the max is the y-coordinate of the vertex. So what was that wonderful formula that's written nowhere? Negative b over 2a. So I'm going to have x is equal to negative 1.2 over 2 times negative 0.02. What's x? I don't have a handy-dandy calculator. Anybody? Nobody else with a handy-dandy calculator? 3? Does it work? It's 30, isn't it? You might have just missed a 0. So if x is 30, what's y? Really? Yeah. Johnson. It doesn't. It doesn't. It's terrible. There's Snapchatting during math class. You were not. It's Snapchat. Oh. Now. 98. So this point here is 30 and 98. This point here is 0 and 80. So yes, nothing like I don't have increments, but I've got coordinate pairs labeled on my graph, so I should be good. So where do we go from that? It says graph is to determine whether the owner increases or decreases revenue from the ticket sales made with the draw for new fans. To draw new fans, sorry. Reading my own sentence with the heart. So what does that graph tell us? You need to be able to look at a graph and interpret data from it. What does that graph tell us? And okay, what's a certain point? Okay. So max revenue at 30 games. What happens after that? What happens after this point? What happens to my money? Starts to go down. That is not an unreasonable question to put on a test or an exam. Okay? right, so develop an algebraic model for P of G and explain what it means. Okay, what is N of G? What equation was that? Sorry? Okay, and what is A of G? Pretenders. So, noisemakers, and let's say I have 10 noisemakers, and I have 30 people in the class. What are the chances of you getting a noisemaker? 1/3. You've got 33% of the chance you have, right? So this P does not mean profit, even though we're just talking about money. The P here is the probability. It's the probability of you getting one. So my guess is that if you would just, if this was a question on the exam, you would put P as profit and moved on. Right? Because we just dealt with revenue. And in 10.1, we talked about revenue versus profit. This time the P represents something different. It's not profit, it's probability. It's a ratio question. So what goes on top? What's my numerator? Okay. Equals 2 minus 0.05 G over 8 plus 0. 0.2G, maybe I think that's the way, I'm not sure. Okay, so what is the chance of receiving a free noisemaker? So you create the equation. It's the probability of you getting a noisemaker. What's the probability of you receiving a free noisemaker and attending meeting 4? Where's that 4 going to go? It's going to go in for G, because G is the number of meetings. So the probability, oh, I screwed up. That's the wrong number on the bottom. It's the right number on the top, it's the right number on the bottom. Is it 8.8? Oh, that's not right. Okay.
Yeah.
Judge your hands.
What if someone was laughing at me?
You were laughing at David, not me?
No.
Oh, then that's okay. You feel free to laugh at David. Sorry. All right.